GameSide.com. GameSide.com. What's up, people? My name is Professor Chris Ferguson, and welcome to lesson on SQL tables, or Relational Database Management System, RDBMS. I kind of go with DBM, Database Manager, but database programming, lots of acronyms we have to deal with. SQL stands for Structured Query Language. DBM stands for Database Management. If you're going to write SQL commands, you need an SQL database. The two that we're going to look at are SQLite, good thing for Python programmers. An SQLite database, the setup is automatic. The second one we're going to look at is called MySQL. It's a very famous one. It's used all over the internet, probably the most popular one out there. MySQL does require a setup before you can use it. If you're a beginner, I suggest a program package called XAMPP. And XAMPP, free to download, it's open source. And on XAMPP, you start the MySQL server by running the XAMPP program. You can see I started my Apache server and my MySQL program. And then this admin button next to it will run a program called PHP MyAdmin. PHP MyAdmin is a utility on many hosts that can create and edit databases, tables, records. It's a setup utility for you. And if you're going to run MySQL on your computer, you're going to have to run this program and set up a database. You can see you just type in the name of the database and say create it, and you're done. My suggestion, if you're a strict beginner, go with SQLite. If you have some website experience, maybe you've done some web programming, then maybe try MySQL. SQL tables. Tables, tables, tables. Relational databases store data in row and column format. After you create a database, the next step is to create a table. For a table only created once, you may use a utility like PHP MyAdmin to create the table. For tables created repeatedly, write a setup script to run at the start. This slide, we're going to look at writing that setup script. For example, every semester I have to set up 5 different classes with 4 different tables. I wrote a script to do that. That's not a one-time task, that's an every semester task. So I wrote a little program that I can run at the start of the class and set up all my tables. Import SQLite 3. This is version number 3 of the program. Step number 1, we have to pick a database. Beginner SQL programmers start with SQLite. It's the easiest setup, and for most applications, it's enough. It is a single user, single computer database. MySQL is a network-based DBM. It's used for larger websites or applications where data is accessed from multiple computers. The good news is the basic SQL commands are the same for all DBMs. It's pretty simple. If you plan to run your database from one computer, SQLite should be fine. If you plan to run your database from multiple computers, probably go with MySQL. Connection equals SQLite3.connect testDB and print connected to SQLite. The first connect will create a file called test.db and automatically create the database for you. The object variable connection will be used to send SQL commands to SQLite and to write and read from the database. Later connects just open and select the database. The first one will actually create a file on your hard disk drive. With no directory information, that file should be in the same folder or the same directory as your Python program. MySQL setup and connection is a little more complicated, but once it's done, the code is very similar. You do have to set up a database in MySQL. Here you just have to connect to it and it's ready to go. I do want to point out how important the connection variable is. It is your connection to the database. It runs through the SQLite software all the way to the hard disk. You'll issue a command through the connection and it will write the data to the hard drive. Query str equals create table if not exist myTab. So the table we're building is called myTab. Then we're going to set up a column 0, which is text, not null, and the primary key, and a column 1, which is just plain text. SQL is structured query language. This is the SQL command to create a table named MyTab with 2 columns. Column 0, which is plain text and it's a primary key, and column 1, which is text also. There are not a lot of SQL commands. They're easy to learn. ChatGPT also makes it pretty easy. If you describe the SQL command you want, and then ChatGPT will write it for you. One thing I do want to point out about this line of code is it's creating a string only. The command has not executed yet. Nothing has happened on the hard drive. This is just creating a string which has an SQL command that will send to the database. Cursor equals connection.cursor. Result equals cursor.execute query string. This is the line of code that sends the SQL command to the database. Connection.commit. Whoop, there it is. Execute sends SQL command to active cursor connection, which then writes the table on the disk to test DB. This is not a record. It is the table info. It needs to write future records to the database. Connection, cursor, result are object variables that access the database and any data returned by SQL command execution. One of the things I like about SQLite is you can actually see it. When you first connect to the database and create it, you'll see an empty file on your disk drive. After you create this table, you can open that file with a text editor and you can see the table setup in the file itself. I urge everyone, once you test this software, to go look at your database file and see what it's writing to the file. Print create table MyTab complete. A simple message to verify the execute of SQL create table command worked. It only prints if not an error during the entire try block of code. Try literally means try the indented code. If any code should fail, it will skip the code below it and jump to the accept command. For example, if the connect call fails, it jumps out of the try block, execute doesn't run, and accept runs. What am I talking about? Try commands is literally try this indented code. If it tries to execute the connect and fails, it will immediately jump to the accept and skip all the code below it. It's an immediate jump from the failed connection to the accept command. Now, if it works, it'll drop to the next line. If that works, it'll drop to the next line. All of this code is working. It'll just keep executing the code in the try block. What happens if it's this execute that fails? If it's the execute fails, it will jump immediately to the accept and print the accept. That's why I put this print statement at the bottom of the try block. If this line of code is reached, none of these lines failed. They all worked, and I confirm that there. And if everything went right in the try block, it will jump the accept and continue on with the program. Here's the accept block. SQLite 3.error as error, and then print the error message. This is very important to print the error message so you know what went wrong. This will tell you whether the connect failed or the execute failed. This is error checking. It's so important. Try accept is called try catch in other programming languages. It is a cleaner error handling mechanism than an if-else for every SQL call. When no error occurs, the accept will be skipped. When there is an error, it will execute. Make sure to print the error message in the accept. The alternative to try accept is to put an if statement after all of these SQL commands, after connect, after cursor, after execute. Try accept is a much cleaner way to code and still check for errors than writing if statements after every SQL command. We do have a design decision to make. Technically, create table only needs to execute or run once. The if not exists will mean it doesn't hurt if it runs a second time or a third time or a fourth time, but we only need to create the table once. I will scroll down and show the rest of the program, but keep in mind you might want to pull this create table command and put it in a separate setup script. That's what I do for all my classes. I write a setup script that creates the database, creates all my tables, installs some initial records into my tables, and then the main program doesn't have to worry about that. Well, did you see the scroll? We'll continue on with the same program after the table has been created, and now we'll add data to the table. I'll do another try except and set up some queries to insert some data into my database. Query 2 equals insert into my tab, column 0, column 1, the values row 0 and ABC. It kind of reads like in English, insert into table values row 0 and ABC. The pattern is simple. We create an SQL command, we send it to SQLite as a query. SQLite will create, insert, etc. per your SQL command. MySQL does the same thing. This is the exact same code you'd write if you were using MySQL instead of SQLite. Patterns are important to computer science. We create a query and we use the connection to send the query and have the database execute a command, be it create a table or insert data into a table. An SQL string can be tricky. In query 2, notice the single quotes around row 0 and ABC. These are required if there are spaces in the data. Single quotes required inside of double quotes. Notice the outside has double quotes on it. So inside, I have to use single quotes. If you don't do it that way, it totally messes up the string. The single quote column 0, column 1, that part is optional. If you're providing data for both columns, you don't have to put that in there, but many people put it in there. I'll be honest with you, when I was first learning SQL, building these command strings was kind of hard. I'd get them wrong quite often. Now that I'm using ChatGPT, much fewer errors. Result 2 equals cursor.execute query 2. Remember, we already have the cursor object from the previous slide. Whoop, there it is. Execute sends the SQL insert command to the active cursor connection, which then inserts data into table myTab. Up to this point, it has been required setup. This is the real data being stored in row and column relational database format. Follow the arrows. Data, a row, is being written to the disk file. This command query 2 gets sent through the connection, through SQLite, and boom, the data shows up on the disk file. There is row 0 with ABC in it, written to the disk drive. Print inserted record row 0 into the table. We're going to print a message to confirm that record row 0 was written to the database. Remember how try except works. If execute failed, it would have jumped to accept. So when this prints, it means the execute worked. This is a simple file on your hard drive. You could open and read this text file on your hard drive and see the real record written to the database. Another design decision. A setup script that creates a table and inserts initial records will print messages for everything it does. My setup scripts that I run for my courses, they print out a whole bunch of messages just like this one right here. However, if you are building an SQL program for a website, a CGI program, CGI programs tend not to issue messages like that. When you're running a CGI program on a live database, don't print a bunch of messages out to the web page. It usually sends a CGI replay with some sort of order completed message. I guess what I'm trying to say is when you're writing setup scripts, print a lot of messages. When you're building web pages, make sure the messages match your website. Query 3 equals insert into myTab the values row 1 DEF. Build an SQL query to insert a second row into the table. Like lists, we number from 0, so row 0, row 1, row 2, etc. Column 0, column 1, column 2, etc. It kind of reads like English, insert into table values row 1 DEF. The pattern is simple. Create an SQL command, send it to SQLite or MySQL as a query. SQLite will create, insert, etc. per your SQL command. I build a command and then through this connection send it to the database and it executes the command on my database. An SQL string can be tricky. In query 3, notice that the single quotes around row 1 and DEF. That is a requirement because I'm using double quotes on the outer string. And they are definitely required when there are spaces in the data that you're inserting into the database. Now notice I left off the column 0, column 1 like I did up there. It's optional. If you're providing values for all the columns, you don't have to list the columns. There are many ways to create an insert SQL command. I'm showing you two of the main ways to do it, with column headings and without column headings. Result 3 equals cursor.execute query 3. Whoop, there it is. Execute sends SQL command to an active cursor connection, which then inserts the record into the table MyTab. This is real data stored in row and column relational database format. Follow the arrows. A new record, a row, is written to the disk file. This command execute right here, there's the command query 3. It gets sent through the connection to SQLite, which then writes the data out to the drive. Now, to be honest, this data is not very exciting, is it? I have to keep it short, and I wanted to really highlight that the data is stored in row and column format. So I named my columns call 0 and call 1. I put my first data as row 0 and the second piece as row 1, just so you understand that tables are written in row and column format. Print inserted record row 1 into the table. Another print message to confirm record row 1 was written to the database. Remember how try except works. If execute failed, it would have jumped to except. So when this prints, that means execute worked. If this command failed, it would have jumped over this code to the except command. When it reaches this line, it means the command above it worked. Once again, you could go open this data file on the hard drive and see that the real record was written to the database. The beauty of using a database management system is they handle all the read and write to the disk for you. But it is nice to kind of go open the file and look at it. Connection.commit accept SQLite 3.error as error. Print the error message if the accept executes. Try except is called try catch in other programming languages. It is a cleaner error handling mechanism than an if-else statement for every SQL call. When no error occurs, commit executes and the accept will be skipped. When there is an error, it will jump to the accept and make sure to print the error message in the accept statement. Connection.close. Very important. You must close the connection when you are done. The operating system buffers the data and only does the actual write to disk when it has a full sector. The close will make sure any data sitting in the buffer will be flushed out to the disk file test.db. And you can see our connection is now closed. We can no longer send SQL commands through SQLite. Did you see the pattern? We created 3 SQL commands. We executed all 3 SQL commands and it created a table and wrote 2 records to our table. To wrap up this rather long example, we created a table and stored 2 rows. You can see the 2 rows written to my disk drive right there. This is data stored on disk, and in the next slide we'll learn how to extract the data from the table and use it to display information on a web page or an application. SQL select. Select is the command to extract data out of the database. I like to call it table in, table out. You are going to set up and add data to a table in your database. That is your table in. Then you're going to execute commands to extract data from that table, and the table it extracts is your table out. So if I were to go to my database and say extract the rows where the level equals 2, the SQL program will go through and find a level 2 here, a level 2 there, and will extract and return a table that only contains the users on level 2. Here's my table in. I'm going to run a command to extract the columns screen name and level. It will grab just these 2 columns and return an output containing just those 2 columns. Here's my table in. Here's my table out. Now, you don't have to extract entire rows or entire columns. You can be very, very specific with the SQL command. I'm going to extract the rows that contain Yahoo, and I only want the columns email, player ID, and money. So I'm going to go here and in my main table, look for everything that contains a Yahoo, and there's one here and one there. Once I find those two rows, I'm only going to grab certain columns out of there, the email address, the player ID, and the money field. Do you see the table in, table out? Here's my input table. And after I execute an SQL select command, here's my output table. As a database programmer, you will learn the SQL select command. It is the #1 command that we execute on a database. And now is the time to read the data stored in a relational database table. The SQL select command will select some data from the table. You might say it extracts data from the table. It is the most important SQL command for accessing the information in a database. This table right here is currently sitting in the players table on my hard drive, and I'm going to write a program to extract some data from that table. This is our main table. This is the data stored in a table named players. Other code has written this data, and we have created a connection and cursor to the database. The field/column names above are technically not data stored in the record, but are important for accessing the data. This data right here is written to my database in the players table. Query equals select star from players. I want to select everything from the players table. Select and from are SQL keywords or commands. They are uppercase, so they're easier to spot. They don't have to be in uppercase. The star is a wildcard that matches everything. Players is the name of the table we want to access. We read this out loud as select everything from players table. Cursor.execute the query that we set up above. The information extracted by the select query will be held in the cursor object. Since we asked for everything, it will contain the entire table because of the star. Select means be selected. Most queries extract a subset of the table. This one does it all. Grabs everything from the table. It's the easiest select command you can execute. I basically asked for every row of the table. Return list equals cursor.fetchAll. Very important. The fetchAll takes the result of the execute query on the line above and creates a simple Python list of each record the select found. Return list subscript 0 would contain the record for Bob. Return list 1 contains the record for Tom, and so on. A list is like an array in other programming languages. What this command does is says, build me a Python list with every row from this table, or every record from this table. Print number of rows equals the length of return list. len is short for length. Start simple. Use the function len to get the number of rows or records returned by the query. This is your search returned X matches type of data needed to display items. You go on the internet and search for something, it'll say, hey, I found 10 matches, or I found 4 matches. Take the length of this list and you know how many matches were found by your select command. Return list is a standard Python list object containing every record from the table. For row in return list, grab the first row that was in the players table. Extract a row or record from return list. This is a standard loop code for any list. Return list will contain all 4 records. This will extract the first row of the 4. Since each row/record has 5 columns in it, or fields, row will be a list with 5 slots. The first time through this for loop, row will contain this row of the data. Print row 0, row 2, row 3. Simple print just to confirm the data in the row, the record. I would have printed all fields if I had room, but I have to be selective to make sure it fits. Note how column 0 or email is row 0, column 2 or SC name is in row 2, etc. It's a table. Row 1, column 2 is TomTom. Think about it. Row 1, column 2 is this value right here. And this print statement will show you the email address, the screen name, and the level. Row 0 is this column right there. Row 2 is this column right there. And row 3 is that column right there. And you can see those are the 3 pieces of information that came out. Just because you extracted the whole row from the database doesn't mean you have to print every piece of data in that row. We hit the end of the loop and we came back up and execute the for again. We're going to extract a row or record from return list. This is standard loop code that works with any list. Return list contains 4 records. This will extract the second row of the 4 records. Since each row/records has 5 columns on it, row will be a list with 5 slots in it. The second time through the loop, it'll grab the second record. Print row 0, row 2, and row 3. Simple print just to confirm the data in the row/record. I would have printed all 5 fields if I had room, but I don't have room. Note how column 0, or the email address, is row 0. Column 2, or the SC name, screen name, is in row 2, etc. It's a table. If I went to return list 1, 2, it's TomTom. Row 1, column 2 is this field right there. We've hit the end of the loop after we print this message out. It's time to spin back up and go to the for loop again. I'm not going to go through each and every record here. Let's just say we've spun twice more in the loop and we've extracted the last 2 rows and printed those records for John and Mac. This is a standard loop through a list. Eventually the for will reach the end of the list and return false and exit the loop, which then jumps past the except command. So what we did is we spun a couple more times in this loop. We printed the last 2 records. When it went back up again, it ran out of data. And when it runs out of data, this for loop is false and it gets out of the loop. And since no errors occurred, not only will it exit the loop, it will skip past the except and continue on with the program. So this loop spun 4 times, we printed 4 records, and on the 5th try, it ran out of data and left the for loop. Let's do a new example. We don't have to grab every record out of the table. You know, that's kind of a rare thing, right? I want to print everything in my table. Let's be a little more selective and see where the name select came from. Select means select just certain data out of the table. So we're going to select ID, money from players where money is greater than 20. All we're interested in is the ID column and the money column. We don't want the whole record. We just want these 2 pieces of information, ID and money. And on top of that, we only want that when money is greater than 20. Select, from, and where are SQL keywords. I like to put my SQL keywords, select, from, and where, in uppercase letters so they're easier to spot, easier to read. It is called select because you can select any row/column you want. You do not have to extract the entire table or record. I'd read this out loud as select columns ID and money from players table where money is greater than 20. Cursor.execute the query. Boom, I just grabbed some data out of the database. The information extracted by the select query will be placed in the cursor object. Remember, table in, table out. Here's my full table in. I want to extract a subtable or a subset of the data and build a smaller table, and that's my output, my table out. Data is the smaller table extracted from the larger table. Here's the full set of data, and I grabbed a subset of it right there. This is my table in. This is my table output by the select command. Select the intersection of columns ID and money and the rows where money is greater than 20. Return list equals cursor.fetchAll. Very important. The fetchAll takes the result of the execute query and creates a list of each record the select found. Return list 0, in this case, would contain the first row of table out, and return list 1 would contain the second row of table out. These are the only two rows where money was greater than 20. And now we want to loop through and print them out. For row in return list, extract a row or record from return list, the smaller table out, as a normal Python list. The column 0 will be the ID, column 1 is the money. That is what select query does. It extracts a subset of the rows and columns, and now we're going to loop through that subset. Print ID and money greater than 20 and print the entire row. Simple print just to confirm the data in each row. Note how the column/fields ID and money is in the record and nothing else. We didn't ask for the full record. We only asked for the two columns. Select extracts a smaller subtable. We don't want to always grab every record. We don't want to always grab every column. We want to grab a small set of data that we can print onto the screen. And here it is, ID and money greater than 20. That's kind of hard-coded there. And there's the entire row that the query returned. Hit the end of the loop, spin back up. For row in return list, you never know how many rows it's going to return. Sometimes it could return 0 or 2 or a dozen rows. You don't know how many are going to be returned. So these for loops are really nice. They just go through every entry in the list and allow you to print them out. We will extract a row or record from return list, the smaller table out, as a Python list. Column 0 will be the ID, column 1 is the money. That is what a select query does. It extracts a subset, and now we are going through each row of the subset. Print ID and money greater than 20, and then print that row. Simple print just to confirm the data in each row. Note how only column/fields ID and money is in the row or record. Select is very selective. It extracts a smaller subtable. It doesn't grab the whole row, it just grabs what we asked it to grab. Once again, we'll hit the end of the loop and spin back up. When we do, for row in return list, extract next row record, but we're at the end of the list here. We only grabbed 2 rows, so after spinning twice, we are at the end of the list, so it returns false. End of data or EOD has been reached. Exit the loop, skip the except, this code is done. I spun twice, I printed both rows it returned, and when it got to here, it said there's no more data. I will leave. Notice how it jumped past the except. If no errors occurred, it will never execute the except. Whew. Okay, a quick couple more queries, right? Just to show you how you can change data in a table. I'm going to set up a query where I update players, and I'm going to set money equal to 15, where email equals John at UCLA. I'm going to go to this row, and I'm going to update the money for John. When I execute this query, it will find this record and change the money to 15. It's a pretty straightforward SQL command. Update a table and set a new value for money where the email is set to John. And all this happens out on the hard drive. I don't have to worry about it. I don't have to write the code to do it. SQLite or MySQL will do all this work for me. Update the players table. Set SC name equal to ace where the ID equals 67890. There's ID 67890. We want to update the screen name from TomTom to ace. And when that query executes, an ace now appears under the screen name for this ID. You get the picture? It's pretty straightforward. We set up SQL commands, we send them to the database, and the database does all the work. We've learned at least 4 SQL commands here. We've learned create table, we've learned insert into, we've learned select, and now we've learned update. Go update a piece of data in the record. Whew, that was a long slide. I hope you didn't lose you. You can always go back and rewatch any piece that you didn't get. That is sort of the gist of SQL programs. You set up a string with an SQL command, and then you send it to the database, and the database does all the work, does all the changes for you. I've written programs both ways. I've written my own files and done my own updates, and I've used SQLite to do it. And SQLite, once you get the hang of it, is easier. Now it's obviously time to learn SQL commands. Let's write the SQL commands to create a car database. SQL stands for Structured Query Language. And in the old days, you'd buy a book and you'd start looking up the commands in a book, but they were never what you needed, so you had to do lots of edits to them. Then along came Google, and Google helped tremendously with this. You could Google things like, show me an SQL create table command, or show me an SQL select command, and it would show you one. But once again, you kind of had to edit what it showed you, and you had to learn it well enough so you can edit it. You do need to learn the commands and syntax of the SQL language to effectively use it, just like you need to learn commands and syntax of Python language to program in Python. The big new thing is we no longer have to use a book or Google to learn SQL commands. ChatGPT turns out to be an excellent way to learn SQL. So let's use ChatGPT to teach us SQL. Learn SQL commands. First and foremost, when you use ChatGPT to learn and write SQL, understand the word chat. A chat is a back and forth thread on a subject or topic. ChatGPT learns from and uses the previous inquiries on the thread to make better replies to the next question. To create the SQL commands to make a car database, start a new chat. Do not ask questions on a thread you used to write a term paper or some unrelated Java programming thread that you created on ChatGPT. Start with a fresh, brand new thread. On your new ChatGPT thread, make the first question, write the SQL for a table in your car database. Then, as you ask each additional question to write SQL, it will use what it learned to craft better, more accurate, new SQL commands for your database. Create a dedicated chat thread for your database. So I've started a new thread and I pose this question. Write an SQL query to create a table, car table. The key is a character field, license plate or license plate, a text field make model, an integer field year, and a decimal field price. I just describe in English the table that I want to create, and boom, look, create table, car table. There's my license plate. It's a character field. It's a primary key. There's my make and model. It's a text field. There's my year. It's an int. There's my price, decimal. This is fully executable, perfect syntax for creating a table in SQL. I asked ChatGPT to write the SQL to start my database, basically using English. I have to know a little bit about columns and fields, keys, and text versus number data types, but not a lot of technical details. But the answer that has all the technical details, that's perfect syntax needed to create a table for my database. And even better, it's customized to my column names and data types. I can use this with little or no need to edit the SQL command. In the old Google days, I would search for SQL create table cars, look for an example, and then make major changes to it. ChatGPT is Google on steroids. Maybe I'll make a slight change to this SQL, but not much. I might change this char to a varchar. But other than that, this is good to go. The second question I pose is, write an SQL query to add a record to car table using the values from the variable plate, variable make mod, variable year, and variable car price. Boom! Here's the answer. Insert into car table, license plate field, make model field, year field, price field, the values, and there they are. The plate, the make mod, the year, and the car price. Wow! Do you see what I mean by ChatGPT uses the previous question to craft better answers? It took my Python variable names, which were not an exact match, and assigned them to the correct column/field names in the table. It figured it out on its own. And its perfect SQL syntax It knew to put quotes around fields that may contain spaces, and didn't use quotes around fields that probably do not have spaces in them. That's the beauty of the thread. Once I ask one question, it learns what my fields are and then assumes the field names when it builds the further queries. Third question, write SQL to find all cars with cost less than $10,000. Answer, select star from car table where price is less than $10,000. Wow. To be clear, the more specific the question, the better chance ChatGPT will give you a better answer. Often you'll need to edit the reply, so you need to learn SQL well enough to fix or at least spot any issues. But it learns. My field name was price. I purposely used the word cost here because it knows price and cost are the same thing. So it corrected my sort of not exact question and gave me a perfect answer using the price field rather than a cost field. That's why you open your own thread and you ask additional ones. As I'm building this database, as I'm adding new commands to execute on my database, I'm going to keep all of them isolated to this thread, and it knows what the names of the fields are, so it will use the proper field names without me having to type them in every time. Fourth question, write SQL to delete a record with a plate that matches the variable myPlate. Answer, delete from car table where license plate equals myPlate. When a car dealer sells a car, we need to remove it from the table. So chances are we're going to have to write some code that removes a record from the database. It might have missed something here. Are there missing quotes in this SQL command? If a space can appear in the variable myPlate, I would think we'd need single quotes around myPlate. Depends on how you code it, but I'm thinking maybe it made a slight little boo-boo. And here's the deal with ChatGPT. You have to know something to use it. You can't just come in off the street and just, boom, it's going to write you a database and write all the commands. You have to be able to look at the answer and say, is that right, or do I need to edit the answer? And in this case, out of the 4 questions, I found one tiny little edit that I might have made. I might have put quotes around myPlate. License plate, especially those custom ones, they could have spaces in them. ChatGPT is really good with SQL. It's a game changer as far as I'm concerned. I'm never going to Google an SQL command again. I'll go to ChatGPT and they will give me an answer customized to my database, not what somebody else wrote in their database. It writes Python too. However, if it's unrelated Python code, start a new thread. If you want to write Python code that will execute these commands, go ahead and ask your Python questions on this thread. Whew! That concludes our lesson on SQL and SQL programming. ChatGPT is a game changer. Go ahead and learn and practice writing SQL commands using it. Good luck, and I'll see you on the next lesson.